All right, so again, we're looking at properties today, and I just told you right now that it is the most important lesson this year. You're going to use these properties in almost every single lesson, almost every single homework assignment. And those who don't know it or don't know what they're using can go through math fine. But when you understand these properties and how they apply, it's going to help you to understand what you are doing. I don't want to just teach you and tell you, all right, for this problem, do this, and that problem, do that. I want you to be able to think mathematically using these properties we'll talk about today to be able to say, oh, yeah, because of that property, I'm allowed to do this, this, and that. Oh, Mr. A, can we do this because of those properties? Yeah, we can. And some things that I don't even bring up, you're going to be able to bring to the table because you understand properties. Okay, so the first property we're going to look at is called the commutative property. Commutative property. And we're talking about multiplication and addition. So I'm going to split them up to separate them, but really they're basically the same thing. All right, has anyone ever heard of the commutative property before? Okay, does anyone know what it is, of addition or multiplication? All right, Tristan?
It's where it doesn't matter which number is like first. It's still the same answer.
Okay, good. So I'm going to put it in a slightly different way, but that's the idea. In addition, the order of the addends means the numbers that are being added. That's what you call them. That's a technical name, addends. So the order of the addends does not affect, with an A, please, affect the sum. So that's what Tristan was saying. If you have two numbers being added, you can flip them and add them like that. You get the same sum. If you have 10 numbers being added and you change the order completely of what you have on your paper, you will get the same sum. Can somebody give me an addition problem? Not too complicated, by the way. Just give me single digits being added. Two numbers being added. Yep.
8 plus 3.
8 plus 3? Okay, so here's an example. 8 plus 3. Okay, that's an addition problem. That equals what? 11. So does 3 plus 8. Dun, dun, dun. First property of addition, commutative property. 8 plus 3 is equal to 3 plus 8. That's deep. Think about that a bit. Now, how many examples can I give you of the commutative property? Do you know how many? 2? Millions? No, not close. An infinite number of situations. And I'm going to give you infinity in one statement. A plus B equals B plus A. Remember algebra? Remember I told you it makes things easier? I just gave you all the situations right here. You can pick any two numbers. And when I say any two numbers, I mean any two numbers. Fractions, decimals, whole numbers, positive, negative. Any number for A, any number for B, and when I flip the two, it's still going to be true, right? Can you give me any two numbers where this won't be true? And the answer is no. So give me a number, John. Any number.
Negative 11.
Oh, man. Negative 11. Bummer. Give me another number, Sophie.
9.
Okay, what's negative 11? Is that what you said? Negative 11 plus 9? Negative 2? What's 9 plus negative 11? Negative 2. It works for those integers. Again, it works for fractions, decimals. It doesn't matter what type. This is always true. Okay? This is what I want you to memorize when you think commutative property of addition. A plus B equals B plus A. All right. So does anyone know what the commutative property of multiplication is? Raise your hand. Raise your hand. Yes, sir. Yes. The order of the factors does not affect the product. remember, guys, the word affect is with an A. That's an action word. Oh, that's a good way to remember it. E is the noun form, affect. Oh, but does not affect the product. So the order of the factors does not affect the product. All right, give me a single digit multiplication problem. Two numbers. Yes. 8 times 9. All right, 8 times 9. All right, what's that, everyone? 72. Which is the same as 9 times 8. Man, really? Yeah, oh, yeah, really, yeah, 9 times 8 and 8 times 9. Oh, 72. Good. That works. Okay, how many examples can I give you? Bummer, that's going to take us a while. Or I can give it to you in one statement. A times B is equal to B times A. That second A keeps looking like a 9. I apologize. Okay. A times B equals B times A. Does the order of the addends affect the sum? No. Does the order of the factors affect the product? No. Now, do you notice how I use the words addend, sum, factor, product? You guys, okay. Let's see if you guys are really paying attention. Does the order of the addends affect the product?
Yes. No. Trick question.
Trick question. I don't know. It depends on the problem. I'm mixing up my terminology. I gotta say it the correct way. Ready? I'll try it again. Does the order of the factors affect the sum? Oh, oops. Does the order of the addends affect the sum? No, right? Yeah, see, I love that. No, it doesn't affect it. Does the order of the factors affect the product?
No.
No. Good. So you guys get I'm trying to get that terminology. What does sum mean? It means the answer to an addition problem. What does product mean, Mr. A? The answer to a multiplication. You're going to see those words throughout your book, and I hope you guys are like, oh yeah, product means multiplication, sum means addition. Guys good on these for the commutative property? I like commutative property. Me likeys. Okay? I like it a lot because that helps me to make math easier for myself. Remember how we talked about math being easier? If you know those products, it will help you out. Okay? By the way, me likeys is incorrect grammar and usage. So just to let educational purposes, do not use that. All right. Number 2, the second property is called the associative property. And how many of you have heard of the associative property? Oh, I hope so. Yep. Associative property. And that word associate there, that's part of the definition of what we mean by associative property. And it's referring to addition and multiplication, and they're very similar. So does anyone know what that is? So some of you have heard it. Does anyone remember what that is? Okay, it's a tougher one to explain. Yep.
Does it involve parentheses?
Yes, it does involve parentheses. And I'm going to clarify something with that because they're going to throw, and I call these curveballs. They're going to give you a problem that looks like, yep, it's that. It's coming at you. You better be ready for it. But it actually changes something that makes you have to think through it in order to hit that out of the ballpark. Because I want you guys to get them all right and not to be tricked when they give you something. Yes?
Isn't it where you can like group different like groups of numbers together?
Yep, that's the key word, grouping. Good job. Grouping of addends. So the grouping of addends does not affect the sum. I'm going to scroll up. Okay. The grouping of the addends does not affect the sum. Okay, so someone give me 3 single-digit numbers. I'm just trying to make this easy so we're not like having to think too hard. Yeah, Caroline? 3, 6, and 8. Oh. All right, we're going to add these all together, and I want to group. I'll group these two together. Okay, so order of operations. What would I have to do first? Order of operations way. Yeah.
Parentheses.
All right, so I do 3 plus 6, and what does that give me? 9, and then 9 plus 8 gives me 17. All right. Oh my. Okay. Now watch. Oops. Now watch what I do here, and tell me the difference between the right side and the left side here. All right. What's the difference? Okay. Ooh.
The parentheses on the 3 and 6 on the first one, and then it changes to 6 and the 8.
Okay, so look here, guys. You see how the groupings changed? I grouped these two together on the left side, and I grouped these together on the right side. Now, here, order of operations, what's 6 plus 8?
14.
14 plus 3?
17.
So do we get the same number?
Yes.
Same sum? Did my grouping change the sum? No. Maybe some of you are thinking, though, then what's the point? We're going to show you the point in a little bit. I want to make math easier for you. If you know this property, you can use it to your advantage. Do you guys like shortcuts in math?
Yes.
Do you guys like tricks in math?
Yes.
Then you better pay attention, because they're not tricks, but it's like using what they already give you to make math easier for yourself. Okay, I need you to know something. Sorry, the music is captivating. Anyway, here I want you to get something. Did I change the order from here to here? Did I change the order? No. So, John, remember how you said associative property deals with parentheses? Yes. But just because a problem has parentheses doesn't just mean you can only use associative. You can actually use the commutative property here using parentheses. So be super careful. That goes for everybody. But that's a good point you brought up. All right, multiplication. You know what? I think you guys are getting this, right? Instead of saying the grouping of addends does not affect the sum, how would I put it for multiplication? Let's see if you guys are thinking. Yes, ma'am? The order of the grouping of the factors does not affect the product. I mean, if you need to write that, great. If you don't, I think you got it. So grouping, I'll just put here to kind of abbreviate. Grouping, that's the key word, of factors. Okay, because we're talking about multiplication. Does not affect the product. So associative property, the grouping doesn't change the product or sum. Commutative property, the order does not change the product or sum. You guys get the difference? Order, grouping. Order, grouping. Don't mix them up. Ooh, we're halfway there. How many of you think these are like kind of like duh properties? Like, yeah, duh. 6 plus 8 is 8 plus 6. How many of you like, I get that, I get that. Good. They should be like that. Because when you're going to see them in algebra, I'm going to say, don't you see that duh statement? What are you talking about? It's right there. We just did this. Oh, and that light bulb comes on. You're going to be like, oh, that's so much easier. Great. Just use these properties. Okay. Let's go to the third one here. These are cool. I like these. I like them all. Wait, I like every lesson in math. Okay, so I'm biased. Identity property. Identity property. I'm going to test you right now here. Identity property. Okay, let me give you a problem, and then I'll give you the properties. So don't write this problem. Oh, yes, sir?
So the order has to stay the same?
So if it's just associative property being used, the order will stay the same. But sometimes you can use associative and commutative at the same time. That happens. Okay, identity property of addition. And these are different, so you will have to write both of these down. Okay, let me give you a problem here. Give me a number. Let's just, any number. Now, it doesn't even have to be single digit anymore. Just don't make it huge so I have to keep saying it and I forget it. Yes, ma'am? Callie. Sorry? 20? Okay, hold on. Okay. Ready, guys? Math problem. I want you to give me the answer right after I say the second addend. 20 plus 0.
0. 20.
Swivl, we're going to delete that. Once again, 20 plus 0?
20.
0.
Okay. I'm going to give you time to recover. Like, what happened? I thought it was 0. Okay. Any number plus, and I'm making this very simplistic so we can remember it easy. Any number plus 0 is that same number, or is equal to that same number. And I'll move in just a bit. All right, someone else give me a number. Yes, Braden?
500,061,000.
No. He said he doesn't want
Five.
to have to say it over again.
500,061,005.
No.
Plus 0
Just
is
five.
what?
Just 5.
Okay. What's 5 plus 0?
0.
5. All right. All the different scenarios. Let me give you a tricky one. I'll give you a hard one. May make you think, all right? 2 1/4 plus 0.
2 1/4.
Okay, that was too easy. This is the property. Any number plus 0 equals that same number. That's the identity property. So this is what we mean by identity. Did I change the identity of A when I add 0 to it? No. And you're like, okay, duh, I knew that. Mr. A, where's the new info? This is introducing you to these properties because what we're going to do in math is we're going to add 0 a lot. And you're like, yes, this is easy. Yeah, it will be if you get it. 0 is going to be added to A, and that's going to leave me with A. Okay? Just remember that. Trust me, it's going to come up in some of the hardest parts of this course. It's going to come up. And I'm going to say, remember the identity property of addition?
0.
Oh, yeah. And then that'll help you out. All right. Yeah, what's the identity property of multiplication, John?
Any number times 1
Oh.
is that number.
Nice. Any number times 1 is that number. So it's different. They're not the same. 1 is added with 0. 1 is multiplied by 1. So give me any number for your sake and the classes. Please make it easy. Jack?
36.
Okay, hold on. 36. Okay, let me think of the math problem. 36 times 1.
36.
Okay, yes. A times 1 is equal to A. I gave you all these possible situations. Now, this one's a cool one because we're going to multiply by 1, but it's not going to look like 1. It's interesting. How can you make 1 not look like 1? Let me just give you, or if you maybe you want to give me a situation. Yeah. Okay, maybe you're like by 1, 1, 1, 1, 1. Okay, I mean, I guess, but here, let me give you another form of 1. Ready, guys? Okay, 200 over 200.
1.
Isn't that 1? Okay, please remember that. You're going to need that. Any number over itself is equal to. So let me give you a math problem. So pay attention so you can get the full effect. Okay, 92 plus 32 over 32. Oh, excuse me, wow. I'm going to change that again. 92 times 32 over 32 is? 92. So that 32 over 32 is like, oh my goodness, what is that? You're like spinning around in circles. No, it's just a big fat 1, and 92 times 1 is 92. Okay, yes, big fat 1. I love 1. 1 is good. In fact, guys, this is interesting. It's kind of funny. In the Greek times, some people used to worship. There was a cult that worshipped the number 1. They went to worship. They thought 1 was perfection. One of the reasons, because of that. And because you use it so much. Yeah, I don't know what they did. I don't really want to know too much, but.
They cut off all their fingers until they had 1.
Okay, I was thinking the classes.
Hey, this is.
Yeah, that's why we didn't have it. We don't have that cult anymore, because things like that. All right, we got the addition and the multiplication identity properties. We good on those? Last property, number 4, last one. Are any of these like deep and like intense, Mr. A? I don't remember what that is. No, it's just something you have to look at and. All right, that's identity. Associative, commutative. This next one is only for multiplication. It's called the multiplicative property of 0.
Everything equals 0.
No. Do you think you know what it is? Yes, Emma Grace?
Everything times 0 is 0.
Okay, any number, I'm going to give it to you like this. A times 0 equals 0. Yeah, you said everything equals 0, but it's really anything times 0 is equal to 0. Yes. All right. Hopefully we'll clarify that. Okay, that's the multiplicative property of 0. Any number times 0 is going to be a big fat 0, and that is nice. That is nice. All right, let's look at one application of these. How many of you struggle a bit with mental math? Like if I had to do problems up here, you're going to be like, Mr. A, please let me write it down. I struggle mentally. I'm not that great at mental math. Like I remember in school when I would sit down, we're doing the mental math drills. I'm like sitting there and I'm looking to the right side up above to kind of, okay, what'd you just say? Oh my goodness. Oh, wait, plus, minus. I'm totally lost. Or now I've gotten more refined. I'm picturing a blank sheet of paper, and as they're saying it, writing down the numbers and adding, subtracting, whatever the operation. I struggle with it. I would say if you're good at it, you better keep practicing. If you're not so good at it, like me, you still need to practice. If you're not good at something, you just give up and do something else, right? No. If it's something that can help you or that will benefit you or others, just start practicing. So what I do now is I practice these things. All right, mental math. All right, let's go. Okay, I did well. I didn't do so well, but I have to keep getting better. So if you're good or bad, you need to make sure you practice this. All right, look at example 1 on page 23. So here we're actually on an example. This doesn't mean you can't write anything on your paper. It just means you're not going to work it out. You're not going to carry. You're not going to use the extended multiplication process. You're not going to do that. All right, so example 1. And we're looking at A. So these are in your notes. Do you guys see where it says find the value of each expression mentally? Oh, man. You got to be kidding me. Okay, so let's look at the original problem. This one is 17 plus 13 plus 15. All right, so that's the problem. So do that mentally. Okay, some of you, you're like, okay, good, I got it. Let's do something with this. The way it's looking like here, I'm like, oh, man, that's 28 plus 17. I'm already stuck. What if I did this? I'm going to rewrite this problem and do that. So what's 17 plus 13, everyone? 30. And 30 plus 15? 45. So we get 45. What's 13 plus 15? 28 plus 17? 45. Okay. All right. Somebody raise their hand and tell me which property was used to go from this problem to this problem. Answer carefully. Yes, ma'am. Associative property. Because what was changed? The key word? The groupings. The groupings changed. Did I change the order of these addends? No, I changed the groupings. Why did I change the groupings? Somebody tell me which one's easier, this one or this one? They're the same problem. Top or bottom? Because these two give me a nice multiple of 10, 30, and 30 plus 15. I can do that, 45. This one, I'm struggling a bit after this. I can do that, 28, that's not too bad. And then 17, 38, 45. Okay, that's just a little help. All right, B. So 1B. The problem they give us, 2 times 16 times 5. 2 times 16 times 5. All right, so I'm looking at this one thinking, okay, 2 times 16 is 32 times 5, 60, 160. Nice. But, John, what can I do to make this problem maybe easier for me?
You can put the 2 with the 5, and then the times 16, so then all you have to do is 10 times 16, which is 160.
Oh man, it's 160, and 2 times 5 is 10, right? 10 times 16 is 160. Which one's easier to do, top or bottom? Bottom. Which property did I use? Raise your hand. Which property did I use there? Yes, ma'am? Callie? Commutative property. Commutative property. You didn't, it wasn't like, oh man, we totally changed the problem. No, you changed the order, boom, you get the answer. easier. Okay. All right, let's look at it. The next three examples are actually pretty straightforward. Look on page 24. These are interesting. Yes, sir? Yeah, go ahead.
Would it be both commutative and associative?
For which one? The last one we just did? Well, did I group any? So did I like group anything?
Well, you did 2 times 5.
Yeah, so first I did 2 times 5, then times 16, but I didn't group them together. Like I didn't use my parentheses. So associative will have parentheses. Commutative may have parentheses, and they'll throw you off with that. In your homework, you will have one where they will show parentheses, and the property used is commutative. So be ready for that. All right, 3. I mean, these are insulting to you, I hope, because you're like, really? They're going to ask me this? Okay, A. What do they say to do in the instructions in example 3? Read where it says rewrite. Okay, Sophie?
Rewrite each expression using commutative property.
Okay, so here's the expression. Okay, algebraic or numerical? Which one is it, by the way? This is a review.
Algebraic.
Why algebraic?
Because there's a letter, one property in the.
Letter, number, and at least one operation. Wow, yeah, thank you. Operation. Yep, so that's an algebraic expression. So we want you to rewrite this using the commutative property. Ready? Next. Okay, did we use the commutative property? Yep, we're done. Okay, B. I'm not even going to write it on the board. B says 4 times S. How do you use the commutative property to rewrite that?
S times 4.
S times 4. Done. You're done. Okay. On these problems, please read the instructions. Some of the problems are going to say rewrite each expression using this property or that. So do that. They don't want you to figure out what the answer is. You're like, Mr. A, I don't know how to add these together. They didn't ask you to add them together. They said rewrite it. So make sure you're careful with that. All right, example 4. This one says rewrite each expression using an associative property, then simplify. So example 4, I know, 2 steps. Example 4, A, what's the expression for A? Can someone read that to me? Yes?
M plus 5 plus 2.
All right, so here's the expression, and now I have to rewrite it using the associative property. So what do? How do I rewrite this? Yes, Tristan?
5 plus 4 plus S.
So I have to write it like this. If I were to move the 5 plus 4 over here, what property am I now using? So if I only use the associative property, I have to move those parentheses between the 5 and the 4, and then simplify. So what's 5 plus 4? 9. So my answer is going to be M plus 9. These two do not combine anymore. We're going to talk about that more. That's algebra. That's all you can do with that problem. It was M plus 5 plus 4, and this is it simplified. Okay? That's as simple as you get. Please do not write 9M, because what's going on between these? What operation? Addition. If you put 9M, what operation is now going on? Yes? Multiplication. So you change the problem, and you can't do that. All right, and then B. This one could be a little tricky. B is 3 times 7t. 3 times 7t. All right, use the associative property, not the commutative, just the associative. Okay, Michael?
3 times 7 times 2.
Okay, so it's 3 times 7?
Oh, 21.
And you're left with 21t. So 3 times 7t simplifies to 21t. What's going on? What operation is going on among all 3 of these? What operation? There's only one. It's called multiplication. What's going on between these 2 numbers? Multiplication. Did we change anything? No. We just made it simpler. We made it look easier to work with. Oh, look at this. Example 5. Last one, and then I'll let you go. Let's see here. Wow, we actually have some time. Yeah, I know. This is example 5. Okay, they want us to evaluate x, y, z. And what does x equal on example 5?
2.
2. What's Z? Or Y, excuse me? 8 and Z. 15. All right. They say evaluate mentally. So you can write the problem down, like you can write this down. But now it's time to do it mentally. 2 times 8 is 16 times 15. Ooh, 166. Oh man, I'm losing it. Jensen, help me out.
You switch around, if you just do 2 times 5 and then do that by 8.
So if I do 2 times 15 and then times 8, is that what you're saying? What's 2 times 15?
30.
That's 30. And then what's 30 times 8?
240.
And my 240. I'm writing down my mental steps. So I'm not, you could write this down, but mentally means you're doing this in your head. You can multiply 3 numbers in your head, yeah, if you switch around the order, which means which property did I use? Trick question here. I hear commutative. You sure about that?
Yes.
Associative, I hear now. Sure about that?
I'm sure about mine.
Okay, listen to me carefully. One of my tactics of teaching, what I use to help you guys out, is I'm going to question you and try to make you doubt. Ready? How many of you think it's commutative property? Okay, Elizabeth, you think it's commutative property, right? Are you sure about that?
Yes.
It's not associative property,
No.
but it has parentheses.
But it's not grouped together.
Yeah, but you had 3 numbers up there.
It doesn't matter.
I'm trying to get her to doubt, and because she knows the answer, I can't do it. I can't make her doubt. And so she's correct, and I'm testing you to the point where you get to, Mr. A, no, I'm right. Please stop asking me questions. Leave me alone. Okay, and then I will, and you're right, and we're all good. Okay, good. All right, your homework tonight. These are actually too bad if you read the instructions. 16 to 42. 16 to 42. Oh my, that's a lot. It really isn't if you look at the problems. And please read the instructions because, Mr. A, we had to work out all these problems. Some of them said rewrite this expression. That's all you had to do using this or that property. So I hope you guys follow those instructions. So 16 to 42, and then 51. And that's on page, make sure here, page, 25, just 25. And you can go ahead and get started. If you have questions, you can ask. I am here for that. And hopefully we'll get to this pattern where I can get done and give you time to work. So on a separate piece of paper, not on your notebook, you can start doing 16 to 42. And we're going to end this recording.